Hello Internet! Today we're going to talk about sys.monitoring, which is a new module in Python 3.12. Python 3.12 has a lot of new features. One of them is low overhead monitoring built into the runtime. This is supposed to be helpful with the fact that we have to monitor applications in production. And if runtimes externalize interesting events, that means we don't need to develop crazy hooks into introspecting into those ourselves. That means that we can have a really good interface to low-level interesting events within the runtime. Python has decided to externalize branching calls, opcodes, jumps, and some returns and iterations and all sorts of like interesting stuff, yields, unwinds, like really truly like control flow and interesting things. And I have no idea how to use this API, and we're gonna learn it together. So let's get started. I've prepared a small file here, which has nothing but importing some random gibberish like numpy and random in order to sometimes branch and sometimes not. And if we do branch, then we do some heavy computation or we do some heavy IO. This is going to, this is actually not that heavy. We can try to maybe, let's go with 50 megabytes, just so we'll have something interesting running here. So this is IO heavy, this is CPU heavy, and we sometimes do that and we sometimes do the other thing. And apparently sys monitoring still does not even have proper types. So we'd need to actually introspect ourselves and see what's happening. So let's go with pip install IPython and let's open IPython and import sys monitoring. Awesome. So we do have that in our interpreter, just we don't have indices for that. So let's try to understand what we can do here. Help on module sys monitoring in sys. So we have something that's called tool ID, and we have local events registering callbacks. So this looks interesting. This might be the thing that we actually want to do. Let's try to understand how do we register this thing, because we have a tool ID here. So we probably need to like allocate ourselves one of these IDs. So let's begin. Let's have an event called something happened, and this would be the callback, and we don't know anything about it. So let's just do this here. What we'd like to do is maybe let's help ourselves with this. Let's copy this help up to here. Looks all right, and paste it here, and then Copilot will maybe understand our API. So kind of, we probably need something like first registering the tool. So let's see, we need to say use tool ID, and this is a number between 0 and 5. Actually increase the size of this a little bit. So we have that. This returns none. So this just means we need to allocate it, and if it's already in use, then apparently we're sad. So use tool ID, and then what else do we need to do? We can use free get tool, turns the name of the tool. Okay, so this is the name of our script. Sure. Let's register this callback with, how does that do? Register callback. This monitoring register callback, event tool ID, event int func callable. Okay, and if we'd like to like register to all events, then apparently we need to do something like iterate over all event types. Okay. We can do that, but for event ID in events, we'll figure it out in a minute. And we now we have now registered everything, and we can actually try to do this as a context manager. That might be useful. So context lib context manager and tool ID and int, and we say something like this, and this is not restart events. This would be something like free tool ID. That's true. Free tool ID. Yep. Okay, so we now have our own monitor, and this one we need to figure out, and then we can do this with the context manager, and everything will be sort of fine with monitor 0. And let's try to understand what do we want to do here. So these events, we have them somewhere as a list. Monitoring events. Looks like an enum. This is the namespace. Can I iterate over this? No, that's quite sad. Can I make this into a dictionary? No. Let's try to understand what can we do. I'd like to get everything here. Oh, so this is just, this looks like bits. That's quite nice because we can actually just have them all. Probably like with just saying monitor 0xff, and this is it. So how about we just try to run this and see what happened. And we can quit this. Yeah, Python, monitor me. This quit quite quickly because apparently I forgot to run main. The callback can only be set for one event at a time. So this is quite sad. But what if I want to like listen to all events? But sure, let's just go with this. Come on, Copilot, help me out here. So we can just say this monitoring events. So events, yeah, that's the right thing. And call, probably. Let's go with call. And we have some time wasters running, but we don't see any callbacks. So is this happening? Print, monitoring started. So this is happening. Call 16. I resume jump. Let's try jump. So is this not what I expect it to be? Let's try to understand what happened here. So maybe we need to like enable the tracing themselves somehow. So let's try to say something like enable everything. Tool identifiers, events. So this is the list. We have tools. Where's the enable? Let's try to figure it out. Turning events on and off. Oh, that's nice. So set events, tool ID, get events. Returns the end representing all active events. Activates all events which are set in event set. No events are active by default. So can I register everything? Just need to iterate over this and not like combine it into one bit flag. So let's go with event need to be this monitoring event jump, and we say set event and then register callback for that event. Maybe this will work. Something happened. Takes 0 positional arguments, but 3 were given. Amazing. Args, key args. Woo! So we are seeing some things running here. That's nice. So first of all, this probably adds like a lot of overhead when we're doing this in Python land. But if we'd have that in a C extension, that would be nice because we could like maybe offload this work to, I don't know, another thread that's not like the main Python thread. That could be nice, but this is good. This is actually working and like we're getting some things here. So let's try to understand what happens here. So first of all, args is always an empty dictionary, so we can just ignore that. And let's try to understand what is actually happening here. So what do we have here? We have our code object, which is on the main module, kind of address. That's all right. This is probably just the actual like main function. And I'm surprised because this is a jump, right? So this is an if statement, and this also is an if. So I'd expect to see jumps in 2 places, not in 1 place. Let's try to understand why is that here. And we have line 67 every time. Let's run that again. And we have always line, so it's always line 67, which means we're only branching here. Line 67 is the code object main itself. So this does not look like a branch to it because, well, there is no code here. Maybe it's actually specialized to be, yeah, sure. Well, it's the opposite way around, but yeah, let's go with false and true so we can mimic the fact that this is actually printing branching. This is not branching. This is. So we are still not branching, which is like we're not seeing this branch. We're not seeing this function, which I'm surprised, but let's try to not think about it too hard because I don't know how this module works. But we do have our reportings here. What happens if we now say, yeah, so it's a jump, it's not a branch. Okay, this might actually be useful for event in D. Let's register the callback, and this will fail. No, okay, so we can register multiple callbacks to the same handler. We just need to register them separately. We cannot use the same flag twice. But what we have here, so let's try to zoom out a little bit so we'll have a little bit more information on what's going on here. So here we have, now we can actually see like jumps inside library code, which is nice. Code object, sometimes branch. Awesome. So we're seeing the branches and we're seeing the jumps. Apparently the jump is not this jump. It's not the jump from the if to the else branch. It's from the while true here. Okay, nice. So this is cool. I like this. Hopefully you learned maybe like the monitoring now exists natively in Python, which is nice. Probably this will create a whole age of new profilers, which will be useful, less overhead, and would maybe give us like way more information about like things where they're happening, because now we won't have to waste a lot of resources to introspect into things in order to get information. So maybe there are like low-hanging fruits now for what we can monitor easily and efficiently. And I'm excited to see what people actually try to do with this tool. So hope you enjoyed it. See you in the next video.